You are welcome to solve this nice algebra problem, which is k times k times k. Subtract k times k is equal to 100. So what is the value of k? So k times k times k, this is k cubed. Subtract k times k, which is k squared. This is equal to 100. So let's take 100 on the left-hand side. So this is k to power 3. Subtract k to power 2. Subtract 100. This is equal to 0. Now we have k to power 3. Subtract k to power 2, subtract 100, which you can express as 125, subtract 25. This is equal to 0. Now from here, we have k to power 3, subtract k to power 2, subtract, now 125 can be expressed as 5 to power 3. Now here, negative times negative, this is plus 25, which is 5 to power 2. This is equal to 0. Now we have k to power 3 and we have 5 to power 3. So here we can write this as k to power 3, subtract 5 to power 3, subtract k to power 2. We have k to power 2 and 5 to power 2. So k to power 2 plus 5 to power 2. This is equal to 0. The next step here, we have that k to power 3, subtract 5 to power 3, subtract. Now we can write this as k to power 2, subtract 5 to power 2. This is essentially equal to 0. In this case, we have two parts here. Now we have the difference of two cubes expressed as a to power 3 minus b to power 3. And the second part here, we have the difference of two squares expressed as a squared minus b squared. Now, the difference of two cubes expressed as a cubed minus b cubed, this can be expressed as a minus b, a squared plus ab plus b squared. Now from here, we have k to power 3, subtract 5 to power 3. This can be expressed as k minus 5. Here we have k to power 2 plus 5 times k, which is 5k, then plus 5 squared, which is essentially equal to 25. Let's call this equation 1. Then we have the difference of two squares expressed as a to power 2 minus b to power 2, which we can express as a plus b, a minus b. Applying this property, then that means that k to power 2 subtract 5 to power 2. This can be expressed as k plus 5, and then k minus 5. Let's call this equation 2. So from here, let's combine equation 1 and 2. Now, by combining equation 1 and 2, we have k minus 5, k squared plus 5k plus 25. Subtract k plus 5 and k minus 2. Now you can see that k minus 5 is common here. So let's factor out k minus 5. So here we'll have k squared plus 5k plus 25. Okay, subtract, here we have k minus times plus 5, this is minus 5. This is equal to 0. Now here we have two parts here. The first part is k minus 5. This is equal to 0. The second part here, this is k to power 2 plus, now we have 5k minus k, this is plus 4k, and then 25 minus 5, this is plus 20, this is equal to 0. So from what you have here, k1, this is equal to 5. And the second part here, this is the quadratic equation of the form ak squared plus bk plus c, this is equal to 0. Now from this quadratic equation, we have a equal to 1, b equal to 4, and c equal to 20. So let's assess the discriminant value of this quadratic equation so that we can check the nature of the root of this quadratic equation. So let's substitute b here. This is 4 squared minus 4 times a, which is 1, times c, which is 20. So 4 squared, this is 16, minus 20 times 4, which is 80. So 16 minus 80, this is negative 64, which is less than 0. And here, this implies that we have two complex roots. Okay? So let's solve these two complex roots by applying the quadratic formula. So we have k2 and k3. This is equal to minus b plus or minus the square root of b squared minus 4ac divided by 2 times a. Substituting the values of a and b and c, we'll have minus b. This is actually minus 4 plus or minus the square root of b squared minus 4ac, which is minus 64. All this divided by 2 times 1. So here we have minus 4 plus or minus. We can express the square root of negative 64 as 64 times negative 1. All this divided by 2. The next step here, we'll have minus 4 plus or minus. We can express the square root of 64 times negative 1 as square root of 64 as 8. Square root of 64 is 8, and square root of negative 1 is I divided by 2. So this essentially is equal to, now here we can factor out 2, so that we'll have minus 2 plus or minus 4i divided by 2. So let's simplify here, and that implies that k2, k3, this is equal to minus 2 plus or minus 4i. So these are the two complex solutions we have. These are the two complex solutions we have. And then we have that we have only one real solution, which is k1, which is equal to 5. So let's verify that k1 actually satisfies the equation. Now let's verify that k1, which is equal to 5, actually satisfies the equation. Now, if you recall that k times k times k, subtract k times k, this should give us a value of 100. So k is 5, so this is 5 times 5 times 5, subtract 5 times 5, this is equal to 100. 5 times 5 times 5, this is 125. Subtract 5 times 5, this is 25. This is equal to 100. 125 minus 25, this is 100, which is 100. So the left-hand side is equal to the right-hand side. And that affirms that K1, which is the only real solution here, satisfies the equation. So thank you for watching. Kindly follow the steps, like this video, and subscribe.